Hello everyone. In almost every video in this series, there would have been mention about any one of the OOPS concepts in Java. You might have heard the terms OOPS, inheritance, abstraction, etc. a lot in those. Finally, in this video, we are going to look at Java OOPS concepts in detail. Today's video will not contain a complete example chapter like we usually do. The purpose of this one is to conceptually articulate about OOPS concepts in Java. There will be upcoming separate videos that will dive in deep with examples on major OOPS concepts like encapsulation, inheritance, and polymorphism. What are OOPS? OOP stands for Object Oriented Programming. The paradigm in programming where everything is represented by an object is known as Object Oriented Programming. In case this actual definition does not give you the whole picture, let's break down in simple terms. From the name object oriented programming itself, we can deduce that it is a programming language that involves object. Here, objects are the primary source around which everything is defined in the code. Now, what are objects? Objects can be termed as real world entities that can hold data and perform tasks. So, OOPS contains a list of concepts that defines what are objects, what they do, how they communicate with each other, and perform various tasks among them to achieve a goal. Before knowing about OOPS concepts in Java, you must know about access modifiers, non-access modifiers, and methods. The prerequisite to this video would be episodes 3 objects, classes, methods, and variables, 5 access modifiers, and 6 non-access modifiers of this series. Why are OOPS concepts used in Java? When we talk about Java having an advantage as a programming language like simplicity, reliability, modular, robust, secure, etc., they are predominantly due to OOPS concepts in Java. The reason for Java being an object oriented programming language is due to all the advantages that OOPS provides. In addition, since OOPS deals with real world entities, it helps us to provide solution to real world problems more efficiently and effectively. It provides a clear, defined structure programs which makes the code easier to maintain, modify, and debug. As it makes the implementation easier, it provides a way to create complete reusable applications with fewer code and shorter development time. OOPS concepts. What are the major OOPS concepts in Java? Objects, classes, data abstraction, encapsulation, polymorphism, and inheritance. In this, if someone asks what are the four major OOPS concepts in Java, your answer would be abstraction, encapsulation, polymorphism, and inheritance. Classes and objects. We had already seen in detail about classes and objects with the third episode of this tutorial series. So, here let's recap with a quick summary. Class is a template or a blueprint based on which objects are created. It describes the state and behavior that object of its type support. It is only a logical entity, not a physical entity. An object is created from a class. An object is a basic unit that represents real world entities. In other words, an entity that has state and behavior is an object. It can be physical or logical. In most of the cases, it will be a physical entity. Memory is allocated as soon as the object is created. Real world entities are nothing but the things that are available in our real life. So, it can be a car, bike, pen, chair, or anything. To compare and explain class and objects, assume car is a class, a blueprint, or a template, where the blueprint is it should have tires, body, brake, etc. Now, the objects of the class car can be Mercedes, Ferrari, BMW, etc. An object consists of three characteristics: identity, state, and behavior. Identity is unique ID internally maintained by JVM. State represents data or attributes of an object, and behavior is a task or operation performed by the object. State is defined by collection of variables and behavior through methods. In our example, the properties of a car, color, model, doors, etc. collectively make up the state. Braking, changing gears, accelerating, etc. collectively represents the behavior of the car. Abstraction. Data abstraction or abstraction is a process of showing only the essential information that is needed and hiding the non-essential information. For real world example, when we break down to actions on the car, say you are pressing the accelerator, the speed is increased. You don't need to know the internal working of how the speed is increased. All you care about is press the accelerator to increase speed. In Java, abstraction can be achieved through abstract class and interfaces. For detailed information, please refer to episodes 6 non-access modifiers and 7 interfaces of this series. Encapsulation. Encapsulation is defined as the wrapping up of data under a single unit. That is, it is a process of binding the data and the code into a single unit and keeps both being safe from interference or misuse. This mechanism binds the code and data it manipulates together. Thus, it is a shield that protects data from being accessed from outside objects. This is somewhat can also be termed as data hiding. Encapsulation and data hiding terms are interchangeable. Considering our real world example car, we will look at car as a whole. The car will contain data like color, model, etc., and operation like accelerating, braking, etc., all bound together. Car can have state or data in the form of variables like color, model, entity type, is left and right, etc. Now, if you give public access to all these variables, then you are exposing the entire state of the car class and entrusting whoever uses it to properly use them. This is risk, and I have already mentioned in the past videos that providing public access to instant variables is not recommended. In such cases, we encapsulate the field, that is, define color, model, engine type is left and right variables as private and have public getters and setters methods to access and set values to those variables. Other popular real world examples would be application forms, etc. All domain objects in Java are defined with encapsulation for data integrity and security purposes. Almost every application in Java would have encapsulation. You might wonder by now, both abstraction and encapsulation in some manner performs data hiding. How encapsulation is different from abstraction? The answer would be elaborate, which will be explained on later videos. For now, just consider if access to specific data is provided, that's abstraction. Whereas encapsulation hides the data and the user cannot access directly. Abstraction focuses on what should be done, while encapsulation focuses on how it should be done. Polymorphism. Polymorphism is defined as many forms, or it is a process performs a single action in different ways. If a single task is performed in multiple ways, then it is called polymorphism. In Java, this is done with the help of signature and a declaration of entities or method. That is, methods having the same name but different in number of parameters or type of parameters or different in return types. For our real world example car, you can lock the doors remotely and through voice command. The task is locking the door, which can be performed in different ways. So here lock door would be a method. If no parameters are passed, then it is remote lock. If a string parameter is passed, then lock the door over the voice command. Other popular real world example would be how would you react to people of different age in a particular situation. There are two classification of polymorphism: compile time polymorphism and runtime polymorphism. Compile time polymorphism can be called as static polymorphism achieved through method overloading. Runtime polymorphism is also called as dynamic polymorphism achieved through method overriding. We will look at them in detail on later videos. Inheritance. Inheritance is the mechanism in Java where class is allowed to inherit all the features of another class. The feature involve fields or variables and a method, generally occur with parent-child relationship. That is, when the child class acquires all the properties and behavior of a parent class. In Java, inheritance is achieved by using extends keyword. Inheritance is also is a relationship. The main terminologies on inheritance in Java would be super, refer to the parent or super or base class. Subclass, which inherits the base or parent or superclass. Subclasses are also known as child classes. There are five types of inheritance in Java: single level, multi level, hierarchical, hybrid, and multiple. Classes only support four types of inheritance except for multiple inheritance. Only interfaces support multiple inheritance. We will look at inheritance in detail on later videos. For real world example, if the car class is extended by classes Mercedes, Ferrari, etc., then it is inheritance. Other OOPS concepts in Java. Whenever OOPS concepts is spoken in Java, only the major concepts that we looked at so far were mentioned. But there are other OOPS concepts which were less spoken about. They are coupling, cohesion, association, aggregation, and composition. Aggregation and composition are types of association. Coupling. Coupling in Java indicates the knowledge or information or dependency of one class to another class. This means that if properties or behavior of one class changes, it affects the other class also. There are two types of coupling: tight coupling and loose coupling. Tight coupling, if one class is strongly related to another class. Most of the time, inheritance with extends keyword will have a tight coupling. Real world example for tight coupling would be car and Ferrari. The Ferrari class is entirely dependent on car class. Any changes on state or behavior of car will affect the Ferrari class also. Loose coupling. If one class is weakly related to another class. We have already seen on interface episodes that it supports loose coupling. Real world example would be car implements engine, brakes, interfaces. Cohesion. Cohesion in Java indicates to the level of class or object which performs a single well-defined task. That is, it measures how the methods and the properties of a class are meaningfully and strongly related to each other and how focused they are on performing a single well-defined task. High cohesive classes are good for code reusability. Low cohesive classes are difficult to maintain as they have a less logical relationship between their methods and properties. It is always better to have highly cohesive classes. There are two types of cohesion: low cohesion, high cohesion. Low cohesion indicates unrelated properties and methods, while high cohesion indicates only related properties and methods. For example, if the car class has unrelated properties and methods, say music button variable, then it is low cohesion. If there are only necessary properties and method, then it is high cohesion. Association. Association in Java is a relation between two separate classes that establishes their relationship with the help of their objects. The relationship can be between two or more objects. There are four types of association between objects: one to many to one, and many to many. For our real world example car, the relationship between Ferrari and the class is one to one association. Assume relationship between car class and a passenger class. That would be one to many. Association can be classified into two types based on relationship direction flow as aggregation and composition. Aggregation. Java aggregation is a weak association. It represents a relationship between an object containing other objects. It indicates a part of a whole relationship where a part can exist without a whole. Aggregation represents as a relationship. It is one way or unidirectional. For real world example car, consider car and a passenger. Car can have multiple passenger. If one passenger is removed, car can still function without passenger. Composition. Java composition is a strong association. It represents a part of a whole relationship where part cannot exist without a whole. Without the existence of one object, there is no chance of another object can survive. For real world example, consider engine and vehicle. Engine cannot exist independently without vehicle. After every topic, there will be a set of questions with multiple choice options which you can use to self check your skill on that topic. These are derived by me for that topic. You can find the answers in the video description. In case you got it wrong, no problem. Explore and identify what you missed. This exercise will help you learning the programming language efficiently. First question: Second question. Third question. Object-oriented programming in Java simplifies software development and maintenance. OOPS concepts help us to resolve real-world problems, enhance features, and write flexible, efficient, and reusable code. It provides security and flexibility. OOPS is one of the major and critical part of Java. You must be familiar and well versed about OOPS in Java in order to write quality code. In any interview related to Java, the probability of a question being asked on OOPS is 99%. So make sure to understand OOPS concepts properly. Thank you for watching this video.